Hello.
Good morning.
Good morning.
Hello.
Hello. How are you? Hello, Himanshu. Hello. All right. Yeah, so maybe we can get started. We'll have people coming in as we go. So this past week has been pretty good in terms of meetings. We had three meetings this week. The first is the DevoWorm meeting. And so in that meeting, we had a talk on a technique, like an imaging technique, where we're trying to reconstruct images. And, they could be from microscopy, they could be from, machine learning applications where you have very little source data and the like. The idea is it's actually an X-ray reconstruction method, but you can use it probably more broadly. The idea is that this is something that one of our collaborators has been working on in the context of breast cancer detection. But you can use those kind of techniques in a lot of places. So there's someone who's now working on that project in earnest, and they were presenting their work on it. So we had a pretty good discussion on that. Hussein also talked about some of the things he wants to do in the DevoWorm and OpenWorm space, and I've been helping him along with that. So he's going to give a more detailed presentation on that this coming week, so on Monday. And so I look forward to seeing that. So that's our DevoWorm meeting. And we also, in that meeting, I did a presentation at the end on biological foundation models. And so there's been, I think in the DevoWorm meeting a long time ago, we talked about one foundation model for DNA, like using a large language model to analyze DNA sequences. Good morning, Amanda and Jesse. And so, this is an area that's kind of interesting because we usually, when we think of large language models, we think about natural language like English or Chinese or, French or whatever. And so, we have that, but we also have the ability to analyze DNA and proteins. And there are a number of papers out now where they do DNA sequence analysis and protein sequence analysis, and can do this quite effectively with a large language model. So there are a couple of, in the talk, I cover I talk about one model and then one of the other models kind of in passing. And so just to make people aware that that's an application domain. And so that's fortunate because today we're going to have a talk on large language models, and we'll do that in a bit. But the other meeting was Wednesday. That was the Cognition Futures meeting. And in that meeting, we talked about, what was the paper title, Jesse or Amanda? Do you remember?
It was basically something like about interoception and allostasis.
Okay.
And it was by Lisa Feldman Barrett's lab.
Okay.
It was a nice paper kind of associating those things. It also heavily leaned into control theory, tried to relate control theory as more of their take on that as a means to sort of explain their model and they why allostasis instead of homeostasis and things like that.
Right. Yeah, it was very good. A very dense paper, and it needs like a lot of couple sessions to get through, as we usually do. So Amanda pointed out that the title was Interoception as Modeling, Allostasis as Control, and she posted the abstract, so maybe people who did not get to attend the meeting can read. Or actually, we have the meetings on YouTube. You can go watch it. And so it's Cognition Futures. And so those were meetings this week. We also had a private meeting, which was on administrative issues. We had, we talked a little bit about Google Summer of Code and how to strategize for that, and especially with the onboarding. And so I think that'll be fun this summer. We need to kind of always continually reevaluate how we're bringing people into the org, how they're understanding what we're doing, and the materials that we have for people. So we don't approach GSOC in, like, some organizations will be very hands off. They'll just say, here's some code and work at it. Himanshu, of course, and Jesse know kind of our process for that. We have the community period, of course, but we like to really kind of get people immersed in sort of the big picture during that time. I mean, the community period is about learning about your community, but we have like this. We really want to get people some context for the projects, because the projects are not as straightforward as maybe like fix this patch on this piece of code. And so some organizations do GSOC like that. We don't necessarily do that. And so, yeah, we talked about the schedule of GSOC, and we're coming up on the beginning of the application period. So just for people watching, people here who want to apply to GSOC, that application period is starting soon. So you can work on different things. We don't really have the traditional issue structure of a lot of open source orgs, but we do have meetings, and we have, people should be starting to kind of figure out what they want to do for their projects. And that's kind of the way to contribute. And so, yeah, so we're coming up on that, and we're trying to figure out how to optimize that process so that people can be, it's smooth, that we don't have to worry about people falling through the cracks, or people can actually propose some really good things.
Yeah, and I would to further what Bradley said, I would say, I think what's potentially unique. I haven't done a survey of all the different people doing cool summer code, but I think one thing that stands out a bit is there's a definite focus on like professional development. There's a definite focus on how do you, as an early career researcher, early career developer, early career anything, and even different people coming into our lab for different purposes outside of Google Summer Code, there's a very developmental process. So the community period is about the community of the lab, but also the community of kind of engaging with open source, engaging with either academia or how to work or operate in that system, and throughout there's professional development. There's a focus on other things. So part of what I've done is I have a friend, an associate, a contact in who's very familiar with training and education, and it's sort of a nice mix of us getting some sort of an outside perspective on how things are happening here, and then getting a little more experience in engaging with this kind of community. And I think that'll be very fruitful. So we can deliver a little more quality, and I think it will be a very beneficial thing, even just to talk about it, because for many years, I've been a mentor, an official mentor for like a year or two, and I've been in the program. I came to the program. I joined, actually heard about the lab because of Google Summer Code in 2019, and that's when I finished my. I went back to school and finished at that time, and I did not get the funding, but I did. It wasn't really called the summer cohort at that time. I think this is what we're calling it now. But I ended up staying with the project anyway. I went through it, and I went to the meetings and got the experience of it all. And I'm like, oh, I really like this. And I realized I like research, and I liked the lab. And I ended up staying with the lab and a lot of things like that. So there's a nice bit of experience here, and obviously we're really fortunate to have Himanshu and Ankit and Vrushali's been stopping by, and we have a pretty good, and that's just here. There's a lot of other things in Devo work, Hussein has experience with Google Summer Code, and other people, and who are more based in D1. But we have sort of this nice alumni and like, I don't want to say feedback, but a lot of like useful history and people that are still caring about the project, even though time has passed, even though things have developed in different ways, and that's nice, and the history's there, but also sort of the intent to make some nice things happen there, and I think that's really nice. I think it's nice to, it's definitely the highlight of the summer, and people come and go through the season, but it's very much I like what we do here a lot, and I'm looking forward to this summer as well.
That's great. Thank you, Jesse. Yeah, so we'll be following up on that, just kind of in practice. We might have another meeting, but we can actually talk about that in the admin channel as well in the Slack too. So that was good. And then Morgan was there, and if he has any questions or comments about that, he should you can bring them up in the admin channel because I know you work with NeurotechX. You have some experience in how they do things, and it'd be kind of nice if they were doing something we could do, or not doing, that we could do it.
Well, we're certainly, yeah. I also had a meeting with NeurotechX people this week, yeah, it's also dealing with some of the things you don't want to deal with necessarily, which is maintaining your nonprofit status.
Right. Yeah.
And the issues with that, and I didn't realize that the Canadian nonprofit status that they have doesn't allow them to accept donations.
Oh wow!
So there's two kinds. So there's there's nonprofit charity, and then there's nonprofit affiliate.
Oh right, yeah.
Anyway, so we were actually talking about trying to become a nonprofit in the United States, and so anyway. But we were also Alex Aguirre, who's in Boston, and hosted this awesome MIT sponsored kind of I don't know if she would have called it a networking event, as opposed to say a hack night, and she does office hours on Friday to help the new chapters in terms of what's involved in becoming a chapter, things like that. So it's slightly different structure, or yeah. But really interesting to hear how people are trying to grow a community, and yeah. And certainly trying to draw some lessons from what we've done here in the States, how things changed during the pandemic in terms of trying to grow a community, and then how things have worked. Because I co-host the meeting with Paris, NeurotechX group in Paris, which is actually a cognitive science. It's CogLab, which existed before NeurotechX. So this is kind of a student cognitive science organization based in Paris. And yeah, in terms of how they host events and how they try to, to some degree, well, the professional development is less emphasized as the kind of community organizing.
Yeah, the professional development is a nice, I think, addition to what we're doing. Yeah, because I mean, this is like GSOC really is about like kind of tech oriented. I mean, you have people who are probably going to go on to like technology oriented jobs, and some won't, but those skills are going to be useful.
Absolutely.
Yeah.
Yeah. So it's actually more with NeuroFedora. So being a part of Fedora projects, at the same time as GSOC, they're getting a cohort of outreachy interns, and yeah. So just like there's a set of GSOC related projects, affiliated, organizations that have projects. Fedora participates in outreachy, submits a set of projects that they would be interested in getting people working on. And as a part of that, there's a lot of good professional development for people getting into tech and software engineering. Hopefully working on the kernel.
Yeah.
Potentially.
Yeah.
But and we're gonna really. I posted in event discussion or something. The Flock to Fedora is going to be in Rochester, so I think we'll be there, and trying to get a little. It's a great time to get some really, really awesome developers interested in NeuroFedora, and we're going to be making a bit of a push on neuroimaging tools. So I forget who joined recently, but had reached out to me about NeuroFedora projects, and so I'd love to talk about if anybody's interested.
Yeah, that would be great. We try to. One thing that's less well known about like the group is that we have kind of like tentacles in other areas. So, like I'm on the scientific advisory board of Active Inference Institute, and Morgan does a lot of stuff with
okay.
With NeuroTechX and NeuroFedora and INCF stuff, and I'm also kind of affiliated with INCF and OpenWorm, and of course other university positions, and so it's like we all have these kind of tentacles in different places, and so there are a lot of opportunities that are kind of hidden under the hood, and like we can unlock them, but we need to we need to have a conversation if people are interested. Don't be afraid to ask us for some sort of I don't know about off the record, but it's like sometimes you can have conversations with people that are very kind of standard things where they tell you the standard advice, and then if you talk about kind of what you really want to do, or if there's like some specificity to it, because a lot of times people aren't very specific on what they want to do. It's best just to be really specific, and if it's something that you have to, we're not gonna like laugh in your face about anything. We're trying to be productive, but more time often than not, though, those kind of discussions can lead to opportunities you would otherwise not know that exist. And so that's that exists. So especially Morgan and myself, but Jesse as well. He's doing a lot of things with he's he works in a organization. It's like a startup or something, and he's got a lot of experience and different things like that. So.
Yeah, just wanted to say that I've thought a lot about the overlap with the open source sustainability, and what I've seen in terms of how people at Fedora monitor, especially on the release engineering side, and the kind of like the package maintenance and time commitments that go into maintaining certain packages. There needs to be a certain assessment of the sustainability of projects and their utility, but as well like the work it takes to keep them in the release. And I've always thought that again, like Flock to Fedora would be a good time to maybe tap some of those people and ask them about some of their experience, and as well as like what they've seen out there, additional projects that they've seen out there that would be useful, would relate. Active Inference has had some great speakers this past week.
Yeah.
It's been awesome. I
really
didn't realize you're
oh yeah. So we're really about like trying to sort of corral a lot of what they're doing. So like they do a lot of live streams. They do the science streams, they do the
Yeah.
math streams and all that, and like you
Yeah.
get a lot of people, but a lot of that is, people can go to those videos and use them. We're trying to build around like fellowship programs and
Yeah.
other types of things where you can then have people who are working on projects and become sustainable. And so yeah, it's definitely that's an interesting organization. They go a lot beyond like the typical active inference area, but it's yeah, and there are a lot of really good people who are connected to it, like of course Friston, and there are other people, high profile people who are either involved with some of the board activities or been in the live stream. So yeah.
No, certainly learned a lot from them in terms of their community building and
Oh, yeah.
just the way they run meetings, or
Yeah.
like the way the way in which you can do live streams.
Oh yeah,
Like
yeah.
Sorry, what's the UC Davis postdoc
Oh,
there?
Daniel Friedman.
Daniel,
Yeah.
yeah. I mean, just him going through papers, it's just like, wow, we could, I'm getting a lot from this.
Yeah, yeah.
It's like, this is great.
Yeah.
Anyway,
He
yeah,
has this
cool.
whole language of like affordances that he uses too. It's like the whole way he runs the thing is like, what are the affordances we can build off of, and which is I mean, it's like if your first pass at like active inference, it's kind of jargony, but it is, that's what you're doing. So
Yeah, sure. But he's coming from social insects research.
yeah,
isn't
I
he?
think he's
Right?
in
Yeah,
ants.
yeah.
But
That's awesome.
they have a lot of
Yeah.
like different like obviously
Yeah.
from psychology, cognitive science, neuroscience, but then
Yeah.
you have people from like software engineering, and they have a project on software engineering and some other things. So a really diverse group of people.
Yeah, well, they had Jonathan Gerard this week, talking from Wolfram Physics Project.
Oh yeah.
Yeah. All right. I mean, I think he's at a Cardiff Institute now, but talking about
All right. Yeah.
library.
Yeah, that's a good
Very cool.
conversation to follow up on. Yeah.
Michael Levin next week.
Oh, a live stream? Yeah.
Yeah, it's showed up on YouTube. I think the 14th.
Okay. Wow. Good.
Like 2 people, Levin and somebody. I'll check.
All right. Yeah, that's great. So yeah, I wanted to get to updates. If anyone had any updates that they wanted to share, now's the time. And then we'll get to Sarah's presentation, and then I want to review our submissions board. So that's kind of the layout for the first half of the meeting. So did anyone have any or updates that they wanted to give? Okay, Amanda doesn't have any updates. And Jesse, if you want to have a longer update later, we can do that.
Yeah, I don't have a whole lot. I might mention a few jump forward condition features things, but my shorter update is that it's been a good week, and I'm really looking forward to spring and excited for the rest of the year. Kind of waiting to hear back on, I find some summer schools and I'm finishing up this term for grad school stuff. So things are rolling. But yeah, I'm looking forward to this ahead.
All right, good. All right, so I guess well, now we have we'll do our presentation. So Sarrah Bastawala is I think she's applying to GSOC, and she sent me her CV, which was very good and very interesting. And she's going to be working, or she wants to work on the open source sustainability project. And so, that's like Himanshu worked on that last year, or the year before, actually. Last year I worked in DevoWorm. Okay, so yeah, Himanshu says, not a big update from my side. Yeah, I was in 22. Just focusing on academia for a while and excited for GSOC. Well, thank you for joining us, Himanshu. So yeah, Himanshu worked on that project in 2022, and this is it's kind of an open-ended project. So we want to investigate open source sustainability. Why people do things in open source? How do you make projects sustainable? How do you make sure they don't fail? And so we kind of approach this through computational modeling, at least for now. Himanshu did a reinforcement learning model. We did an active inference model and a personality model that summer. Last year we worked on, was R.V. Rajagopalan, who worked on more reinforcement learning, kind of making the model better, doing the web interface, making that better. And now Sarrah is actually proposing to use large language models, I believe. So I'm interested in seeing her approach here. So Sarrah, I'll give you the floor.
Yeah, sure. Thank you for the introduction and the context. Okay, so I'll share my screen and jump right into the presentation.
All right.
I hope it's visible to everyone.
Yes.
So, yeah. Okay. So yeah, as Bradley kind of introduced, like what I want to do is I propose an LLM powered multi-agent framework to simulate open source communities. And like the end goal for simulating this is to be able to encourage conditions and understand what kind of conditions would lead to sustainable practice among said communities. So, yeah. All right. So, yeah, this is like a broad overview, which I think Bradley gave very nicely. That it's the project that has been working. People have been working on it since the past 2 years, and these are the models that have already been created. Most of these, like the simulations, are made in NetLogo, and they have AI or reinforcement learning or other algorithmic backends. So what like I'm proposing an LLM model, and why do I want to do this work with LLMs? So first of all, what I'm proposing is, I mean, when I say LLMs, everyone thinks of ChatGPT or thinks of text. So how do we go from LLMs to agents? So I'm proposing to construct a model that has large language model empowered agents, such that you can think of this as the brain of the agent is the running large language model. And I want to simulate these in an environment not completely virtual. I aim to make this environment as close to the real world as possible. And the way I say this is these LLM agents have perception and interaction. I want to make them have perception and interaction with real world tools directly, like GitHub, Discourse, more tools that are used very widely within open source communities. So this is a really good example, and this is a really good image from a survey paper, which is answering this question of how do LLMs go from LLMs to agent-based modeling, agent-based simulations that I think many of you all might know very well. So the first fact is that this has already been done in a wide variety of domains, physical, social, cyber, many domains. And the blue boxes here are what is ideally believed that an agent in an agent-based model should have, such as social ability, the ability to interact and understand various things from the environment around it, autonomy and reactivity to be able to make its own decisions and act on those decisions, and proactiveness to like be able to take those decisions without any other external stimuli. And on the right side, we see what abilities do large language model agents can have. They can have perception with real world. I'll come to that in a bit. There are many reasoning techniques. So based on this perception, if they have information about the real world, they can reason on them, they can make decisions. And not just that, they can also self-evolve, not exactly in the training or reinforcement way that we know, but in a fine-tuning manner. And based on this, they can take many actions, and their actions can also keep evolving. So so this slide will kind of take you through how do I go from this LLM to an agent perspective. An LLM agent basically refers to an LLM instance. So one instance of an LLM. And here comes the main part where it is equipped with unique attributes. This is mostly done via prompting. The LLM is told you are an agent that specializes in legal activity, or you are an agent that is an open source contributor, and some details about that role and attribute is given to it. And then it is provided with access to various tools there is a the OpenAI GPT API gives something as function calling. So this is where basically anything that can be modeled as an API, the LLM has access to it and can internally call on it and use that information to its benefit. So here is where this main difference comes between just an LLM, because just an LLM only has access to the information that it is pre-trained on, which information would definitely be outdated, and it would also be a vast variety of information. But LLMs equipped with access to these various real-world tools can actually update their information in real time and get very context-specific necessary information available to them. So this brings us to what are the requirements for an autonomous agent. So they are the brain, perception, and action abilities. So here, like this diagram explains it, where if this is an LLM based agent and somebody asks it to look at the sky and tell it, will it rain tomorrow? If so, give the umbrella to the person. Now, ideally, an LLM working in your laptop should neither be able to look at the sky nor give the umbrella. But because of these tools that we have provided with it, it can perceive the sky, not by directly looking, but by accessing the weather API and seeing weather predictions and figuring out will it rain tomorrow. Once it has this real-time data as its information, it can store it in its brain, and then in its brain, it doesn't have just this new information, it also has all of the information that it has been pre-trained on, which is why you can hold conversations with ChatGPT. It understands things. So in a similar way, this large language model will understand that if the weather API says it is going to rain tomorrow, I should give an umbrella. So this is the internal working of the brain of the agent where the real LLM part comes in. And then next is the actions that are defined, which again are access to various tools. It can give the umbrella by either ordering it from Amazon, or if it is connected to some real world home appliance, it can actually bring the umbrella to it. So this is a very toy example, but I think this is how an LLM goes to an agent, and why the benefit of the LLM comes from, because of this huge pre-trained information, it knows a lot of stuff, and that can really be used to our advantage. So this is how it has been used to the advantage in various fields, which are actually very similar to our problem. So again, these are images from the left is an image from the survey paper, which states that this agent-based modeling using LLMs has been done for these fields such as social network dynamics. There is a framework called S3, it stands for Social Network Simulation System, and it again it simulates a group of agents that behave like humans, and they analyze the social communication trends between them. There are very great examples for LLM agents in cooperation and cooperative task solving. One of the really good examples is ChatDev, which can create an entire software system for you the same way software as an enterprise creates it for you. Where it has its entire company, and each agent is modeled to either be the CEO or to be the developer or to be a tester, and hence it can simulate exactly what is happening in the real world. And because it is all software, that, as we know, most LLMs, the most training data they have is of code, so they really know code very well. So it's something that it excels at. And then there are also instances where the individual social behavior is taken into account and analyzed very well. Humanoid agents is another great example of this. So basically, in these social network dynamics or individual social behavior, these agents are, as I said, they're given some role, and along with that role, they are made to emulate humans by giving them various phenomena. Like, we tell them that, when you're starting, it is can be thought of very similarly to as hyperparameters, where we tell it that to start off you have these, this is your value of emotional happiness, this is your value of information you have, and then as you go on, if this happens, your emotional happiness will decrease. If that happens, your information will increase. So these kinds of rules that are just told to the LLMs, and then they're let in the simulation, uh, enables us to actually observe trends that we would observe in real human societies. So the right example is a very the image on the right is another great example of this. So in fact, even in last week's meet, I think last week's meet, if you remember, you all talked about the paper of Voyager, which is how LLM instances are used to play Minecraft. So there is another paper for agent wars, which is basically talks about these collaborative LLMs, and they used it to study how these LLMs would interact with each other. And what they did was they created their own framework, and under it they kind of ran Voyager, and basically they had a bunch of LLM agents, not just one. They had a bunch of LLM agents playing Minecraft in a world that was only agents. And then because Minecraft is this game that simulates human life, not modern human life, but definitely human life to some degree, they found emergent behaviors among how these agents were collaborating, such as in Minecraft, if they were given the same goal to craft one bookshelf, but they were allowed to cooperate as a team, such that it was not every agent's goal to just collect and make the bookshelf as fast as possible. In fact, it was their goal to first discuss, decide that I will collect the sugar canes, you collect the other things we need. We will together come and craft books, and then in the end, we will have one bookshelf by collaborating. But then these were conformity behaviors that they came across, where these agents help each other. But because they simulated real life, Minecraft does have the option to kill people or to destroy things to get their resources. They also observe these behaviors. They also observe destructive and destroying behaviors among these. So basically, all of this is to say that there have been various experiments where we can see LLMs very clearly emulating human actions. And I believe we can use this to our advantage to create a model to formulate our problem of, again, simulating an open source community and understanding what sustainability would be there. The similar way that these other frameworks give parameters of emotional happiness, we can have parameters of productivity and what kind of benefit are you getting in the form of, say, publications or grants or anything else that you're doing while you're contributing to open source. Also, I mean, there are these roles that are that it allows us to define. We can create the hierarchy that is often there within an open source community, where you have one maintainer, one or multiple maintainers. You have developers who are very new, who come, who eventually get more and more engrossed in the community. So this is how I propose to create the model. I propose to map it to a multi-agent system and to define the model in terms of its building blocks, the agents, define them in terms of what is their role, what is their current state, what are, say, they could be told what are their possible states, and the authority that this has, which allows us to create this hierarchical structure. And these can be either predefined or they can even mimic real world roles and authorities that are there within a set organization. So this could potentially it could not just simulate any open source organization, but it could simulate your specific open source organization. And how would it mimic these? Using various plugins. These plugins are basically what these agents would use to interact with the environment. An agent can interact in natural language because these are large language models, and that is one of the greatest advantages we have. But they can also react with the environment using these various tools, these APIs. Even if this is a virtual environment that we end up building, there are various plugins we can create within that as well. And messages to kind of allow these communications. So we need to clearly define how these communication will take place. But so modeling it as this, I believe we can create an efficient model of an open source sustainability this. So yeah, some of my thoughts are like, the reason I came across this is I see many experiments that are being done in this variety of fields. There are a lot of existing open source frameworks as well, like MetaGPT, Agentverse, generative agents, and humanoid agents. These are very well known, and these also allow a lot of customization that I think should help us, because this would be quite a difficult problem to start from scratch. But building upon what these these open source tools have already found, I believe we can simulate it for us. And we can also use as I said in the start, we can use tools that are actively used by the community, like Discord and GitHub. We can have those as the APIs. And there was also in the paper that was published by the lab in 2022, this source cred was cited as a purely data-driven model that actually used data from GitHub and Slack. And I believe we can integrate that into our agent-based model and kind of come very close to simulating this. And yeah, so this is, I said these things in the previous slide, but these are the kinds of data we can get and simulate it. And these are my references, so I would love any questions, feedback.
All right, that's great. Thank you very much. Now, I'm sure we have some questions, so anyone want to start off?
Yeah, sure, I can.
Okay.
Hello. Yeah, so first of all, really good presentation. Like I had like a few questions in mind and some thoughts like I would like to give about the presentation itself. So like when you talked about like the perception and interaction with real world tools, like in that the starting pages, right? Yeah, so this one. Right. So like in this, like are you like exposing the API like while creating agents using something like OpenAI function calling or something else?
I think OpenAI function calling is one of the, like, it is one tool that I've used. I think there are, if you want to use open source models, there are those as well. But I think, I mean, as far as I know, all large language models that are used very commonly, like Llama 2, Mistral, or OpenAI, have like, they can be easily interfaced. There are many code examples because the thing is that we're not changing anything within the model itself. The model remains as it is, and this is one layer above it that just gives it this information. So it would be the same as giving this information to it in a prompt on your own. But the only ability of this API is that it can decide to call this API, and it can decide to take the information in from this API. So,
yeah, so like the advantage of this would be like instead of a system prompt, it will be something like getting some other data from the API and putting it as tokens.
Right. Yeah. In fact, so a system prompt is what is like appended to the beginning of like every chat with these LLMs. That is what helps define their role, the authorities, all these other parameters that are given to them. And yeah, apart from that, it would also like whenever this information is needed, that is what the beauty of the function calling is, that you can tell it in natural language, that if anyone asks you about the weather, use this weather API. Then you hook it up to actually call the API, because everything is being done within software. And then it gets the data from the API. You write some regular expressions to parse it out. It comes in JSON format, whatever. And then once again, it gets in natural language input saying, yes, you asked about the weather, so the weather is this. So, yeah, I mean, this is how it...
So, okay. So, like, it's a JSON format, and then you can use it at the other places.
Yeah, right.
Okay.
Thank you.
Yeah.
Any other?
So I don't know. Morgan had something here. Like
sure. Well, loved the presentation and really interested to follow up with you on some of the references. I just saw a presentation from the developer of Neural MMO talking about multi-agent reinforcement learning and especially tool use. I mean, I think it's really interesting to think about the tool use on it. The question I've always had is, in what way is the open source sustainability kind of being, given as a task? Like what are its unique characteristics, and coming from having been a software engineering manager, as well as having been in a regulated software field, so medical device, is there anything about software engineering that makes it kind of a unique modeling task, or like what aspects of it? And this is more of a general question for everybody. Like, what aspects of it are we trying to capture and to model? To just give a quick example, I love the AI Economist project from Salesforce Research Group, just because they, as a part of the task, there's kind of a work cost, so they're trying to model taxation. And you're, giving the agents some, having to come up with kind of a trade-off between, getting their work done, making widgets, and but also generating enough activity to pay taxes, or potentially to avoid taxes with strategies, right? And again, thanks, Jesse. I'm not sure what aspects of this we're trying to capture, but I think that's always been the hard part. And anyway, yeah.
Thanks for the question. I think what you asked is definitely like a very deep research question. I can try to answer the first part of it from what I've thought of, and then I can tell you things you pointed out that I did not think of. I mean, my first thought while going through these models that were already created, they were trying to emulate human behavior and looking at it from a social perspective. So, which is why they ended up modeling these things like basic needs, emotions, relational closeness. So again, in this, like I did see over there also there was some trade-off. I mean, there is this humanoid agents paper. The example that they give is one of it says that you are an agent, and you need to get this work done, but you have a deadline, it's coming up. So do you stress and do the work, or do you prioritize your mental health and instead call a friend over and take a nap? That is literally an image where like you understand the entire motivation of the project with that one, I would say, illustration. And I mean, this is where I got the idea of modeling it similarly, because all they have done to model this effectively is these three parameters of basic needs, emotions, and relational closeness. Now, the trade-off can be modeled using these, such as emotions. The agent would definitely feel happier prioritizing its mental health. But then, would its basic needs be covered? Would it or would it not lose its job because of missing the deadline? And other perspectives of relational closeness, definitely for the social perspective. But so in regards to these, what I had thought of modeling was participation as a benefit, like as a task, definitely that would have to be done. But then the benefit of different types of knowledge sharing, which could be modeled in mathematical parameters with like expertise or hierarchy growing up, gaining mentorship. You could also have some like proper monetary or say other social credit kind of parameters. And those would be, so there would be one beneficial aspect, one very would given aspect, and then of course, like why would you do it with the community? So the community, what is part of it? So loosely thought of as modeling. Some things that I definitely did not consider, like the worst work cost optimization. I mean, I thought of modeling it as parameters. I do not yet have an answer to how the agents will actually make those choices. And what Jesse said, that is another aspect that I think I've not yet considered, because the community has benefited from members staying. Like, retention is definitely one thing that a community would benefit from. But apart from that, is it work going up in productivity? Are the people that staying actually quality wise? So I think these are the, I mean, to propose this, I have focused on how possible it is, and which is why I've come up with all these different examples, more research on my side, and this being also.
No, but these are follow up on these papers and think about some ideas. Yeah, really interesting. Really interesting.
Yeah. Yeah, we had some things in the chat. It looks like we have, let's see, where did we start? With Jess, and then he's talking about sustainability and sustainability beyond simply retention or people working on the project. I have wondered some about useful or improved archival or future accessibility. So yeah, we oh, go ahead.
No, you finished that, and I wanted to say something else after that.
Oh, yeah. So I mean, we've thought a lot about this. Himanshu's project in 2022, he really did work on like a model of what are the parameters by which we can kind of create plug in numbers. This is one of the things that we kind of focus on in the project during the coding period, is what are the parameters that you can plug in numbers to say they characterize something interesting about an open source community. So I think in Himanshu's case, we had like contributors at different levels of contribution. And so the idea was you had different levels of contribution. You did certain things, you got to a new level. There was like some, also we were modeling sort of, how much effort or how much reward you get, how much, those tasks really pay off, things like that. So there are a lot of, when you model a social system or any system, you have these things that you don't want to model everything. You want to pick the things that are the most salient, maybe the things that you can put numbers on the best. And then, figure out, okay, this thing is going to have a large effect on, say, like my simulation or my model. So, if it's like, maybe it's personality traits you focus on, maybe it's rewards. those extrinsic and intrinsic rewards that we get for, doing things, and if there's a payoff to them. But you don't want to model everything. You don't want to have a million knobs. You want to have maybe 3 or 4 knobs that you can, kind of say these are going to have an effect on this community. If this is at a low level versus this is at a high level, it's going to produce this outcome. And so that's kind of how we want to refine our modeling exercise. And like sometimes, the answers are going to be different. So like Himanshu focused on one way of doing it. You might focus on another set of parameters, because we simply don't know what the best parameters are. That's kind of the whole point of this, is to kind of say, we would have like several different models, and you could say, well, this is a different sort of algorithm, but we're focusing on, certain aspects of the community here, certain other aspects of the community there. And depending on the community that you have, your own community, some things might be more important. Like in some communities, motivations dominate. In other communities, it might be like time constraints or, other types of things that are important. Maybe, you have an established project versus something that's just you're trying to get it off the ground. Well, those are going to be different types of things that are going to have a large effect on that community. So that's really the key to all of this, is getting those parameters correct and saying these are the things that are going to have the greatest effect on the state of the community.
Definitely. I mean, this is what I've always been curious about in terms of like, are you focused on the kind of collaborative, are you focused on the collaborative interactions, or are you focused on kind of like the code output, right?
Yeah.
Which could be a separate thing, right? I mean, it's amazing that we're at the point where we could actually have collaborative agents where there's actually a code product. They're generating code, but each agent is coming at it with different priorities, right? So that you're going through what we would call, a proper process, or certainly a regulated process, where some people are generating code, some people are looking at it from test QA perspective, and some people are looking at it from debugging readability and kind of sustainability and the kind of longevity of the code. And everybody iterating.
Yeah, and I guess the follow up I would have now. Originally, I was just going to say my comment was almost a bit about like almost of the spirit of like we mentioned a long time ago. Like a lot of government agencies are doing quite a bit in terms of trying to make like data management and reproducibility and things in like the neuroscience or those spaces. So it was originally about that, and sort of like what sort of this sort of concept of an aspect, like just broadening. We went in the direction I hope we would go in, which is like broadening the sense of what does sustainability mean? What do we want to do? And I guess I would maybe put a slight additional comment on it at a philosophical level. And I forget if there's something we talked about extensively last time, or just with sort of Brian McCorkle stuff that he was sort of doing the sustainability all a tool version of some things a while ago. But I would say I think part of this, or as I re-emphasize that, I think part of this interesting part of this project is there isn't, and we're not expecting you or anyone else doing this project to know all these fields and cover all these fields. It's sort of a choice. And then why is that choice a good choice? And also almost sort of interestingly getting to places where you can potentially have, like, you have the means by which to assess or model a variety of things, as opposed to having it be sort of a dogmatic or deterministic, here is the path. And I think that's a really interesting space for a lot of things, potentially with LLMs, but also sort of as we get more towards like like kind of a catchphrase is sort of programmatically generated everything, and what are things that can transcend or help sort or filter out all of these different things that are being made, including the assessment, including the models we're making here. So that's kind of another topic, maybe philosophical, but one that I think is worth mentioning here, and we'll come back to later too.
Yeah.
Different ways.
Yeah, Himanshu, you want to say something?
Yeah. So like very good question from Morgan. Like because I'd faced with the same issue. Like how would you like emulate a open source community, and how will sustainability come into the part of it? So like so what I thought of in my way was like so the main part of like sustainability, what like the way I thought of it was retention. So but now like there are other aspects to it as well. So like there is the coding aspect of the communities as well as the communication part of it, and those two are, you could keep them separately, but at the same time they are not really separate, but like it's like communication through code, or like you use the communication parallelly with the code. So in the crux of it, like there is a lot of ways to like have a simulation of like a community of sorts. So like, and actually this is like a very good time to get like a good aspect of the project in it, because like since the advent of LLMs, you can have a really smart agent, you could say, which is able to do code. Like if you make it, if for example chat dev is really good at writing code, and then you could have at the same time like if you're thinking of a community in terms of code, like for example just for example, so like you could have an agent that is very good at coding, but then at the same time you have a reviewer agent which is like really good at reviewing things, and depending on its review it can give us some sort of metric that it has, like from 1 to 10, like you have a really good code, so yeah, you can like just good points for you, and then that is how you can climb up the social ranks of the community. So that is when we are modeling it. The another thing would be like from the community aspect of it is thinking of a particular you could say situation, like if there are a few issues and then I want to solve them, and how you approach to the mentors and how will you do it, and the communication part of it, you could like think of it that way. So like in the project itself, I would say ideally the next approaches would be like if you're building a community, you're thinking of the environment, like what would you use, like will you use an MTP, will you use something else, and how is the LLM agent like accessing whatever the environment is, and are you going to prompt engineer it or something else, like etc. And another thing would be like the belief states of the agents. So like Sarah said at the beginning, like thinking of different beliefs, and how do you think about an open source community member, like, and how will you use the APIs and data across that said hypothesis. So another thought I had was like the hierarchical structure which was mentioned like in the slides, that is good for a corporation setting over a, you could say, open source head. So the head is the one which is like at the crux of it, and they are like giving some task, and you can basically cooperate. The agents are like in terms of reinforcement learning, you would say the multiple agents are like finding a way to maximize the reward for the particular task together. uh, like that kind of hierarchical structure is also good for like a corporation setting. And at the same time, like the plugins which we have mentioned, like the APIs that I use, so are these like can they also be modeled as actions that the agent are taking, or is it like you could think of it in some other way as well? So like for the starting stages, like you can also try to mimic a agent in a particular setting, like, and from there you can build up slowly and slowly and slowly to a different product, and you can build it in such a way that that's how you think an open source community is, like from your experience. So that is a different part of the.
Yeah, thank you, Himanshu. So in terms of data, we've talked about the different places you can get data, and this is especially important for training the model. So, we've used GitHub APIs to get data from GitHub, and that can give you data about like different organizations, like commit histories, and other pull request counts and things like that. But that's only one aspect of a community. Sometimes we're interested in like coding productivity, which is what GitHub would give you. Sometimes we're interested in maybe like discussions, and so that might be like something like a Discord bot or a Discord server API, where you can get information about a Discord server structure and how people contribute to that. So, there are a lot of sources of data, and of course there's privacy in some orgs. They don't like to have you just paw through like user data, but that's kind of the structure of the kind of data that you would get for this. So, if you were running an organization and you wanted to assess the sustainability of your community, you would get you would have plugins so that you could put like a GitHub API in and get data about your productivity in coding, in terms of coding. You might also train the model with like a Discord server, the API that would give you like, conversational, sort of analyze the conversational structure. There might be other APIs for other community things. There are a lot of different pieces of data in a community. And so I wouldn't try to make a general purpose model necessarily, but I think with Himanshu's project, he did do some things, and especially I think last year, we did some things with APIs and getting data out of GitHub, because that's kind of the easiest way to do this, to sort of show a proof of concept, is to go and look at, because GitHub has a lot of analytics already. You can get data, and it kind of gives you this, it gives you a structure for contributions. So you can say there's a sort of a distribution of contributors. Some people contribute a lot, some people don't contribute that much, but that gives you sort of a very opaque window into how productivity proceeds. Like Morgan said, there are different things people are doing there. We don't have numbers to attach to. People are maybe participating more in discussions or meetings or whatever, and we won't be able to capture that with the data. So I would, for something like an LLM or any model, computational model we use, I would be very specific on what it can and can't model. And that's fine, but it's just we have to kind of work from there. Like Himanshu said, you can't start with everything. You have to sort of start with like a little piece. But this is great. And then Himanshu had some comments in the chat. He talked about the Salesforce research project, the AI Economist. So there's a link to it here. This is so they have this project, the AI Economist. Let me share my screen here. I'll pull it up. So this is the AI Economist, an open source framework for economic policy design. This is it's on GitHub. Their vision, or their moonshot goal, which we'll talk about maybe during the community period, about these different goal like moonshots and different things like that, is to build an AI social planner that learns optimal economic policies for the real world. And economics is a convenient place to go because they already have a lot of mathematical models in economics, and you can model social behaviors and trade-offs using those tools. So we already have the tools there. But again, it doesn't capture everything. So it captures this sort of optimal economic policy space. We aim to develop more sophisticated AI policy models that meet usability requirements such as explainability and robustness, to recommend real-world economic policies that improve social welfare, hopefully. And then this project seeks to scale up the AI Economist, which is in Zhang 2020. I'm not familiar with that paper. I don't know if they have a link to it here, but that's the sort of the source of what they're getting at with this. We hope to leverage reinforcement learning and machine learning techniques to develop a tool that will automate and improve tasks such as policy design, evaluation, economic objective optimization, which will allow economists and policymakers to focus on the end goal, improving social welfare. So that's the goal with the AI economist. And then this other paper that Himanshu shared here is this DeepMind paper. So this is emergent bartering behavior, multi-agent reinforcement learning. This is similar to what we were talking about with LLMs. And you can see that, like, you have these different paradigms like reinforcement learning or large language models, and you can do similar things with them. So this is where they're doing bartering behavior with reinforcement learning, multi-agent reinforcement learning, and you can actually use deep reinforcement learning to explore microeconomic behaviors. So these transactions, which are actually also important in open source communities, but this is a choice. Do you want to model that, or do you want to model other types of things? We find that artificial agents learn to make economically rational decisions about production, consumptions, prices, etc. And so this actually, a point here is that economics, and especially the way we think about economics, is very compatible with reinforcement learning, at least with when we think about optimal economic decision making. So this is something to keep in mind, is that this problem is posed, the way they pose this problem is amenable to reinforcement learning. If you were to take this, you were to use like a large language model, you might structure the problem a little bit differently. And that's a thing that we do in social science, is we have to think about, like, how do we pose the problem? What do we want to learn from that social system? So that's a good paper. Thank you, Himanshu. He took inspiration from that for his early multi-agent stuff. So, and then yes, welcome Vrushali. Thank you for attending. We'll have the recording later of this. And then Jess says that's a nice paper. And then he points out, this is Jesse, Josh Tenenbaum at MIT has done some similar interesting multi-agent work. Their paper was about chefs and making things in a kitchen environment. So yeah, Josh Tenenbaum is a AI person from MIT. We talked about his work a lot in the past. He's done some interesting things with large language models, with more sort of cognitive science models, with regular neural networks and other types of models. So he's done a lot of things, and they have a lot of interesting work in this domain as well. So Sarrah has provided a link to her slides. Thank you, Sarrah. And then Morgan had this comment about neural MMOs, and there's also always bugzilla.redhat.com for all Fedora too. And then so Bugzilla is this.
There's no privacy concerns here.
Okay.
Yeah, it's got the history. I mean, it's a general purpose, but if you focus on just the Fedora, you've got thousands of projects, right? And their history in terms of development and maintenance, and etc.
So this allows you to like search for specific bugs in their history.
Yeah.
Okay.
But don't just think of it as. I mean, it's a tracking system, right? So development should also be. There should be specifications for anything that you're actually building, right?
Yeah.
And anyway, there engineers did have solutions before GitHub.
Yeah. I was gonna say, I thought this was like GitHub tracking of like a GitHub issue, but I guess you could do any bug if you assign numbers to them. You could get this.
Yeah. So like as you can imagine from the name, right? This was Mozilla's. This was like a really early Mozilla project.
Okay.
And but I think everybody, or certainly, we went through this process where, as you try to kind of formalize your software development process, you start to take tools that you've got and try and make them into things that you need.
Yeah.
So anyway, yeah, there's a lot more than just bug tracking.
Okay.
Is sort of my point.
Yeah. Well, yeah. That's good.
But I guess one of the reasons that I'm emphasizing that is that there's something to be said for getting the projects. It's you're not developing in isolation, right? So like to me, the sustainability has something to say about working in a larger community as well, right? And that was kind of why I always push AI Economist, is that it's multi-agent, it's multi-agent dynamics, but it's multi-agent dynamics in a larger community. And that's what Zhang, that was kind of the thing that Zhang introduced, was like 2-layer or more reinforcement learning. Okay. To emphasize that there was this kind of, there's a certain amount of work that you're doing to kind of maintain your membership in the larger community, as well as like potentially having smaller groups that are working together. Yeah. But okay, it's super interesting.
Yeah. All right. I don't know if Vrushali had something. I saw her kind of maybe raise her hand. Okay. So thank you again, Sarah. It's great. And there are also other connections. We do things with open source sustainability, but we also are doing these things with Bradenburg vehicles. And that might be another area too to contribute to, once with large language models, once you get it might work on some open source sustainability stuff, but we might also look into the Bradenburg vehicle stuff as well, because this would be very useful. I don't think anyone's done that quite yet, where they're basically embodying a large language model agent in a embodied model, which would be like this vehicle that explores its environment. And we can talk about that later, but that's just to say that we do other things in the lab, and that might be of broader interest than just like the open source sustainability. So
yeah. I would definitely add a +1 to that. Bradenburg vehicles, or developmental Bradenburg vehicles, were the thing when I first came. That was the Google Summer Code project I worked on back then. And now, as I was thinking about that quite a bit with the LLM agent stuff we're talking about here, so to say. But yeah, there's a really good presentation. We'll have to talk about it more, start a lot of discussion. And I know we have other things to.
Yeah. So, yeah, Jesse, why don't we go bring up the submissions real quick? I don't want to spend a lot of time on this, but I want to see.
Okay, this one. So this isn't super updated. But yeah, this should be kind of. I think we're done with that actually now. Yeah, we can go through this so we want to add things to it. Go ahead.
All right. So as you can see, we have a lot of things. Some of them are, maybe in the past. Some are, we always put things on here just to keep ourselves kind of aware of things. Let's see, I have a couple things to add here. And I'm just adding them just for purposes of keeping track of like what's been submitted and what's. So the first thing I'd like to add is this, it's this sort of Society for Molecular Biology Festival on Development. And so you would put, it's the CDEV SMB Festival.
Okay, what was that again?
CDEV.
Okay.
Space SMB Festival. And so this is an event that's going to be happening virtually, and I'm going to be presenting on DevoWorm things at this event, and this is happening on the 18th. So this is already kind of done. I put it together from some of the work from the group, and yeah, it's going to be on the 18th. I'm going to try to record a video this coming week on the presentation so that we have something on our YouTube channel. And then the actual festival, I don't know if they're going to record it. I hope so. And they'll have this stuff out there. But it's supposed to be sort of an outreach thing, but also kind of have an opportunity for people to get exposed to developmental biology, cell biology, that sort of stuff.
Oh, I see. Okay, cool. Let's put this through here. All right. What else should go on our list here?
Okay. Then, of course, well, we have it on here, but the Embodied Intelligence Workshop.
Yes.
It's down there. So that is coming up. That's going to be on the 20th through the 22nd. So yeah, we're. I don't know when it's going to, like whenever we're going to present, because I think you've submitted something, and I've submitted something, and Hussein actually has submitted something.
Did he? Okay. Does he? I think he said he was.
Yeah.
All right. Okay.
So I want to kind of get in touch about that. I want to make sure everyone's like getting their presentations together. Now, they usually have we're usually put into the sort of, I don't know what they call it. It's a session where they give the flash talks or, their a breakout session. And so, again, I would kind of like, if possible, for people to record their talk so we can put it on our YouTube channel, because I don't think the breakout sessions are recorded. And so, it would be nice to have those as sort of a place, sort of a way to reference the work later.
Mm-hmm.
And then, of course, doing it in the session, of course, as well, you'll get feedback from the people there, but not a lot of people will see that. So, but yeah, it should be a good event. I don't remember what Hussein is doing his on. I think it's on actually spatial cognition, which is interesting.
Yeah, it was, I think, that and virtual reality sorts of stuff.
Yeah. So yeah, I'm working on a talk on our well, I guess it'd be Bradenberg vehicle, developmental Bradenberg vehicle stuff. And so I'm gonna try to get that done and recorded next week. So that's kind of my spring break next week. So basically I'm working on things that I'm catching up on. So that's good. But that's happening. And so for those of you who aren't aware, there's this workshop we participate in every year called the Embodied Intelligence Workshop. And it's offered online as a opportunity to view things sort of during the conference, but also after the conference. So they record their keynotes, and they have a good set of resources. So there are a lot of interesting talks on things like soft robotics and embodiment and embodied robotics and other things like that. And this year it's supposed to be really interesting. They have a lot of interesting speakers that go beyond those areas as well. But those are the main areas they're interested in. So, if you're interested in agents, there's a lot of interesting stuff going on in that space. And so, yeah, it's, and then of course they also have philosophy there as well. Mm-hmm. They've had philosophers give talks, and, especially in the breakout sessions. So it's really an interesting kind of meeting of the minds. There are a lot of diverse topics that get hashed out there. So if you're, it's, I think it's embodiedintelligence.org is the link. As we get closer, I'll make I'll make sure that everyone's aware of what's going on with that.
Yeah. Yeah, it's a nice place. We've been there a few years now, and it's nice because it has sort of a low barrier to entry, but also like you have very, very, very high level people there. And it's interesting because I think a lot of times it's centered in like Europe or Asia, and so you you get a little different take on things. It's very different. There can be very different approaches to some of these topics, depending on sort of regional or where you are in the world is interesting, but also like there's been really really good discussions and ideas there, and I still remember like a lot of a lot of nice moments from that event. I also updated our Royal Society one, which I think we're just awaiting seconds until like another month or so for that one, I think.
Yeah, I submitted the abstract
Mm-hmm.
last week, so it was like the 1st of March. I haven't heard anything back yet, so I don't know when we're going to hear back about that. But the form has been submitted, and so hopefully we'll hear back. I might drop Adam an email about it and see if he's gotten it, because I know they got the form, but I don't know what their timeline is. But yeah, we're working on that paper.
Obviously, to update this field because this field's doing a bunch of old things, but obviously we're also deep into Google Summer Code land. I guess we can say the next period is sort of ending here, but it is really the whole summer. We'll say completion. Sure, something like that.
Yeah.
But just to visually put that on the map. Anything else you want to add to this list as I'm kind of just setting up everything else here?
I don't think so. I know that Hussein is at Neuroreality Hack. He talked about that.
He mentioned that, I guess, in Colombia or something in New York.
Yeah, so that's interesting. I don't know if it's on the list, but I'm sure he'll give us a report later on that, on what's going on.
I hope so.
Yeah, so that's a virtual reality hackathon. I can't remember where it's happening. Do you remember?
I think it's in New York.
Okay.
It's physiological signals and physiological signals in the metaverse.
Yeah.
So he's expecting. I mean, he sent me a message saying he's expecting to meet up with OpenDCI and GTech people as well.
Yeah.
So for the GTech's like EEG intracranial recordings company. Yeah.
Okay, that's great. Yeah. Yeah. So that'll be something we'll talk about probably next week.
Yeah, I'd definitely like to hear more about that with the same. So yeah, anything else you wanted to mention for this list?
I don't think so. Anything else coming up? I don't think right now. I think this is the focus on some of these things.
Ankit actually just posted something for the Cybernetics Society. He posted that in the main chat.
Okay.
I didn't have a strong sense of what we could do. I know we talk quite a bit about cybernetic stuff right now.
Right.
But the call sort of it looks like kind of a very open. Like I don't. I'm a little bit. I'd be curious what Ankit was talking about for it. But I think the it's extended to. I'll just put it in here.
Yeah, deadlines for submissions extended to 17 March 2024. This is the American Society for Cybernetics. So this is their sort of what they do. And I don't know what the range of things. Basically, if you want to get a sense of what they're looking for, it's if you look at this Constructivist Foundations journal, which is in the call, or Cybernetics and Human Knowing. And that's where some of the papers will be published. So, I don't know what, I think that this is probably an in-person thing as well. So
there's a virtual component, I believe.
There is? Okay.
I'm not familiar, but I looked at it a little bit last night when it was mentioned. So But I'm mostly curious. Yeah, Rashab's someone who I think did Rashab do Google Summer Code a long time ago too?
No, he's been interested in a lot of different projects, but he's been largely doing startups, I think. So
yeah, he's really deep in like the art and also other like neurotech spaces. He's a really interesting fellow. So I wouldn't mind trying to do something with him again here, but I'm not sure. I really want to hear what he has in mind for that. We'll see what happens.
yeah. So well.
Okay. What did you say he was involved with? You said neurotech?
Art and neuroscience or neurotech stuff. I forget what his latest deal is.
Gotcha.
Yeah, he does a lot of stuff with like. Well, I know that he's done a lot of stuff with like machine learning and reinforcement learning, and of course he's gotten into art and some of the BCI stuff. But I don't know what he's working on currently.
Yeah, I don't either.
He's got a lot of interesting ideas. He was working on a video game thing a while back too. But
Gotcha.
yeah, but yeah, this is something we should try to find out more about, because I just kind of looked at it. I didn't really know if there's like a virtual component. We should definitely do it, because we've been talking about things in cybernetics. And
yeah, that's what I was thinking. Like, I don't even think Rashad knows. Like, we have our cybernetics rating group. Yeah. Like, we've been especially talking about like, we just talked about this 1970s paper that's super steep in somewhat more classical cybernetics terminology, and went bounced into, Lisa Feldman Barrett with her control theory take on things and allostasis and whatnot. And we've been doing a lot of time with Levin's work too. I don't know if Rashad really knows we've been doing that last couple months. So there's a lot there. Yeah, hopefully he'll come back around and talk about it.
Yeah. So we can, I can let him know. So let's I see that's on the list. Another thing about the EI conference, going back to that, is you have awaiting acceptance, and I think that should be maybe like preparing. I don't know what our categories are. Maybe like preparing talks or something, because it's more at this point. It's more of a light the fire under yourself situation. I mean, you have to produce something, right? And yeah. Preparing submission. There we go. Yeah. So I think that's it. So now I guess we're waiting for some of these things. We're preparing talks, which is always the challenging part. Anyone can write not anyone can write an abstract, but you can write an abstract and get that submitted. And it's like 200 words, but then if you have to put together a 15-minute talk, or even worse, a paper, that's where you have to actually produce. And that's what we're trying to do here, is we try to make sure that people get to that endpoint. It's all too often people just kind of like forget or aren't motivated to get to the endpoint. But yeah, this is great.
Yeah, I'll clean up these. These are some older things here that are kind of not action right now.
Yeah.
Let me look at one other thing. In the actual, we have a call for involvement channel. This isn't. I don't know if this is so much an event, but something I kind of want to mention is there's a really cool causality workshop at actually my home university right now, UC San Diego, and it's being led by a few faculty that I loosely know, and the less than ideal situation is that it's actually in person only, but I might go anyway because it looks really cool and be a great excuse for me to do some things there on campus, because I'm not based in San Diego right now. Right. But it's a causality workshop, learning and causal knowledge for advancing AI and scientific discovery. So sort of how causality, one of the Bai Wei Huang I believe, it does a lot in the causality section or field, and I'm really curious about using that for scientific advancement and kind of what's happening in that space. That might be a really fun place to look at some of the faculty that I'm kind of interacting with and what they're doing in that way. So that's kind of on the radar. I don't yet know exactly what's happening there. Oh, also, I hope I didn't miss it. That one with the McGilchrist one. There's like a virtual component. As more as like a workshop, but it's not really a CFP. But that was something pretty cool. Yeah, the end of this month, the McGilchrist one. It's up. I don't know. I'm looking at Slack right now. I'm not at what you're sharing, but it's up a little bit further. Just above that one.
This one, analytical. Oh, nope. This one up here.
Yeah, that looks really interesting. There is a virtual component to it. The prices were a little weird, but that's cool too. I don't know if I'll put it. Oh, maybe I'll put it on here. I'll put it just to remind myself about it.
Okay. And they're burying the lead, which is Michael Levin's going to be there.
Yeah, exactly. And some other folks, really cool too.
I mean, lots of others. Lots of others too. Yeah.
Yeah, a lot of interesting events. There's this analytical philosophy and e-cognition. That's an international workshop. Then the Dizzy Summer School, which is diverse intelligences. I think Hussein and Jesse are both talking about this in the Slack. I know that Jesse's already applied to this, and and so this is in person in, I believe, St. Andrews in Scotland. So that's Oh, go ahead.
It's Edinburgh, and it's they also do the Many Minds podcast, which is really cool. The same group does them, which is about diverse intelligence. The whole thing is about diverse intelligence, and it's really nice because they bring together the summer school is bringing. Speaking of Michael Levin, speaking of, I don't even know. Maybe I don't know if it's because I recommended Danny Bassett so often, or Danny Bassett was actually a complexity person there. But they're past invited people to talk, and the experts that they bring along are really good. And I've been applying for a long time, and I hope to get in at some point. It's been hard when you're not like a graduate student in some form, because we have there's just so much, people have so much talent and stuff there, and experience. So but yeah, they really intentionally bring together. What's really cool is they bring together like computation, they bring human development or human-centered intelligence and machine intelligence, and also like non-human other biological intelligence. That's kind of their three tracks. And they say, okay, we want a really big, diverse crowd of people from these different backgrounds to come and talk over the summer. And they also have a storyteller opportunity for, like, there's a scholar and like a storyteller or like designer or art track too, which is separate. And Jenny from Plot Twisters did that a couple of years ago. She's actually based in Edinburgh anyway for her master's program. It's something futures, Edinburgh something futures program.
Yeah. Yeah, I know what you're talking about.
So it was convenient for her that way, but also Jenny's amazing and a great designer, and she had a great time with the storyteller program, which led to a bunch of other stuff that I know. Jen and I worked together on Plot Twisters, but we've done some other. She's been close to some other like research stuff that we've all looked at too. So really cool group, and I was happy to.
This is closer to Dundee though than Edinburgh.
Oh yeah.
Yeah.
Oh, sorry, St. Andrews.
Not that there's anything wrong with Dundee or St. Andrews.
I wouldn't know. I've never.
Yeah. I was up in Aberdeen, so I went through them on the way back to Edinburgh. But yeah.
That's great. So this channel, call for involvement in events, deadlines. If you're new to the Slack, this is where we post a lot of these events. All sorts of events here. Some are sort of in person and maybe not accessible to everyone. But some of these are virtual. Some of these have like web components where they post talks. So it's always good to check and see what if you're interested in something, if there's something to interact with. This is the latest one, network neuroscience. This is always a good. It's actually a satellite of NetSci 2024, and this is always a good session to go to if you can. They have a lot of stuff on neuroscience networks, like networks in the brain. There's also connectomes.
Yeah. I should have put a thing about NetSci.
Yeah. So yeah, NetSci is in Quebec City. So
definitely worth going to both.
Yeah. I don't think it's virtual this year. It was virtual for a while, but
what is wrong with everybody?
I don't know.
Like what? Yeah, sorry. It's just funny that climate match is becoming a thing, and we're dropping virtual conferences.
Yeah.
Like this is not compatible.
Right.
or sensical.
Right.
I mean, in the sense of like, how can you talk about DEI and like not make all conferences virtual, at least hybrid? Anyway, sorry.
Oh no, I'm glad you're having this conversation because I'm wondering the same things, and I'm like, well, if you want to have like, involvement, participation, and not travel all over the place, and I mean, it's expensive to travel to different places to just present something for 15 minutes.
I totally get the difference of an in-person meeting, and like the problems of Zoom are an interesting research subtopic.
Yeah, I know.
In terms of its lack of certain social cues and social, reciprocity, but.
Well, you can replicate those in person. That's not a problem.
This is research. It's like it's disseminating information. Like,
right.
Make it open to people.
Yeah. I mean, if you've ever been to a conference, you know that you can have like, good conversations in person, but you can also have a lot of glitches and things that are not so great in person too. So, I mean, it's just, if we could perfect the virtual component of it, that would be great. I think, maybe people are working on that, maybe not. This is something, I wish our group could do more of because we're really reliant on that virtual component. But
that the fact that I was just in radiology for way too long, where they would have CME courses, like CME courses in Costa Rica.
Yeah.
Like you're not even. They're not even there.
Yeah.
Just going for the trip. Anyway.
Yeah.
But yeah, Neuromatch. Let's I feel like the Neuro AI is new this year, isn't it?
Oh yeah, there's a Neuro AI. So like Neuromatch, for those of you who don't know, was started during the pandemic as a way for people to get the summer school experience when you can't normally get access that. And so I've been a mentor for Neuromatch for several years. Jesse has attended Neuromatch, and a couple other people in our group have either mentored or either been like TAs or participated. And so, it's a really good organization. Now they have this thing called Neuro AI, which is it's kind of like a more advanced version of their deep learning school. But it also brings together the deep learning school with the other thing that they do, now they do climate match, but one of the other things they do, which is the computational neuroscience. And so Neuromatch is open for people to to apply to. So this is the link that Jesse posted here. And so if you're interested in a summer school experience in computational neuroscience or deep learning or some combination of the two, then please apply to that because we'll probably talk about it over the summer as that happens.
And we should be the first to propose developmental AI.
Well, yeah.
do get the right group together to what should be the Dev AI course.
Yeah. Well, maybe we can propose some sort of curriculum. We can do our own thing as well.
We've almost done that. Like I think we've bordered along the curriculum for a long enough time. It's an open thing. Like
absolutely.
This is something like this would be great to sort of advertise as a project or like not necessarily come along as an intern and do this, but it's something that we've had on the burners back and middle and sometimes front, mostly back and middle burners for a long time. And I don't think it's gonna evolve right now, but it's definitely
true. Speaking of, there was I don't know if I put it on. Oh yeah, I did. So in the Dev AI channel, there was a great talk. So Stanislav Dehaene is doing this cognitive science series, what is it called? Models of Human Learning and Cognition. And they had a speaker like last week that was really speaking like very similar to the kind of that NYU science paper, putting GoPros on kids.
Yeah.
Anyway, but I Lisa something. Sorry, let me.
You see that in the middle, and sometimes the petals.
Sorry, what's her name? It was great. Yeah. So how to infants learn, roles, surprise, curiosity, and active experimentation. Lisa Feigenson.
All right. Could you post that link to the YouTube?
Yeah, it's on there. It's just that like the link says models of human learning and cognition, Stanislav Dehaene.
Yeah.
But it's just him introducing the speakers, and I don't like she starts in French and it's the most incredible French. I think she learned it anyway.
Yeah. Okay.
It is pretty impressive, but she doesn't talk in English.
Okay.
Yeah. The series goes back and forth between English and French, but this one's in English.
Yeah. Well, we can talk about that another time.
But developmental AI.
Yeah.
Proposed to Nick Halper. Or get it. A first version here. Yeah.
Oh yeah. All right, well, let's move on from so thank you, Jesse and Morgan, for going over those things. And I want to talk about two things before the end of the meeting. I'm going to follow up on our unorganized machines discussion, but I'm also going to talk about this paper here real quick first. And this is actually, I guess it's a technical report. It's actually, it's on the bioRxiv. So this is a bioRxiv paper. So this is the address here, and this was posted at the end of last year. This is called Rendering Protein Structures Inside Cells at the Atomic Level with the Unreal Engine. So this is Muyuan Chen, who's actually in Cryo-EM, which is electromicroscopy. So this is like imaging things, like freezing them, and then getting really, really high resolution images of stuff at a very small spatial scale. So they'll use Cryo-EM to look at the ultracellular structure of cells and other things like that. So this is at one of the national labs, the SLAC National Accelerator Laboratory at Stanford. So this is a person who does a lot of microscopy, but what they're doing here is they're using the Unreal Engine, which we use in virtual reality and in 3D modeling to build things. And so he's actually rendering protein structures. Now he's not rendering like the physics of he's rendering the physics using the physics engine of Unreal, but he's also not modeling any of the molecular structure. He's just modeling these structures as they appear in the microscopy images, and then using the physics engine from Unreal to model their sort of dynamics. So that's what this picture is here. It's not a bunch of corals, as you maybe think. but it's like the inside of a cell and a lot of the molecules that are in there. And notice how tightly they're packed in, and it's very chaotic. And that's actually what a cell looks like inside. I know, like, people, if you take like an introductory textbook and you look in the textbook, you'll see, like, pictures of very neat and organized insides of cells. So you might get a textbook image where you have the organelles and the nucleus and the chromatin, and it's all nice and neat. And one of the reasons they do that is because it's easy to show students where those things are, and you have to be able to have a mental model. But in the actual cell, things are packed in very tightly, things are very chaotic, and we have to find ways to model that actually reveal the real world of a cell. You can have these models where they're very almost like a spherical cell in a vacuum type thing, where you kind of make a lot of assumptions. You make a lot of simple sort of representations, and you model it. And that's kind of what we do in a lot of biological modeling if we're interested in cells, but not necessarily what's happening inside the cell, but just a cell as a stand-in for a thing that's maybe doing something like a neuroscience model where we're looking at a neuron, or a biological model where we're looking at cells in an organism, in the context of an organism. So the inside of the cell is its own world unto itself, and that's what he's trying to model here. So the abstract reads, well, the recent development of cryogenic electron tomography, or Cryo-ET, so this is a specific technique that involves freezing the sample and then using this electron microscopy, or tomography in this case, to look at the structures or to visualize the structures within the cell, makes it possible to identify various macromolecules inside cells. So these are all macromolecules. These are proteins and other molecules that you'll find in the cell, RNA molecules and other things, and determine their structure at near atomic resolution. So you can get really fine resolution. You can get down to like the angstrom scale, I think, with Cryo-ET or the cryo methods. So you get really, really small, definitely in the nanoscale, and this is important because these things are very small. They're very small. They are either at the nanoscale or maybe at the maybe micron, small micron scale. So this is microns are a level below millimeters. It's micrometers, and then you have nanometers, and then you have angstroms. And so you're just really getting down to a very, very small spatial scale. One of the main hurdles in cell visualization is to render the millions of molecules in real time computationally. So we want to take these molecules and render them in a computational engine. We're not just interested in pretty pictures, we want to model their dynamics. And one of the things that we've done very successfully is protein dynamics, or modeling protein folding. And so we can do this by, taking a model of a protein, a very high resolution model, and modeling its dynamics, which basically means it's wiggling around and it's reconfiguring itself. But these simulations are extremely expensive computationally. You might be able to model like a couple of milliseconds of protein folding, and it takes up a massive amount of computational resources. So that's one problem with some of these techniques, is they take a lot of computation. You get some simulation, but not a lot. And it's really hard. It's a hard problem to solve. Here, using a video game engine, which is Unreal, we demonstrate the capability of rendering massive biological macromolecules at the atomic level within their native environment, so within the cell. To facilitate the visualization, we also provide tools that help the interactive navigation inside the cells, as well as software that converts protein structures identified using Cryo-ET to a scene that can be explored within the game engine. So this is the scene here, and the point here is that it's in the context of the cell. So you have all these things not only there, but interacting in the way, and so forth. So, we're getting data, we're getting this type of very specialized data, and we need to know what to use to model it. So we can use different types of visualization software. This is from UCSF called Chimera X. It can only render one of a few protein structures at the atomic level. So this isn't like if you've heard of how machine learning techniques can be used to model protein folding. This isn't the same thing. This is just a visualization paradigm that they're trying to develop. So they're not, they're trying to model them. They don't necessarily care about a lot of the biological details. There's like this aspect of like physics, like a physics engine, and some aspects of like realistic geometric modeling. But that's basically what they're trying to do here. For cellular tomograms generated by Cryo-EM, the data can only be rendered as slices of grayscale images or segmented volumes with low-resolution protein maps depicting the rough shapes. So the output data that you get from Cryo-EM is this kind of rough approximation of the shape, and you don't get a lot of the detail that you would like. So you can actually reconstruct these using Unreal Engine and building these 3D models, and then that gives you some, it recovers some of what you might find. So, you start with a very low resolution structure, and you can fill in the details with this Unreal Engine approach. And so, while some information such as spatial correlation of molecules can be deduced statistically, direct interactive visualization is still the most helpful way of investigating the interaction between macromolecules inside cells and understanding the mechanisms of biological processes. And so really the problem inside the cell, modeling all these macromolecules, is caused by the large number of triangles needed to render protein structures at high resolution. So we need to create these meshes composed of triangles, the triangles being sort of the degrees of freedom of these virtual models. So if you have a triangle, it means that that's a piece of the mesh, and then you can take another piece of the mesh, neighboring piece of the mesh, and fold it so that you can get these structures. And so that's your resolution constraint. But if you think about the cell and all the things in a cell, you need a lot of these triangles to do this. So just to render protein structures at high resolution, you need a very large number of triangles. For example, a high quality mesh of a human body typically requires less than 100,000 triangles, which is, of course, just modeling like if you were to take an MRI scan of a human body, a full body scan, you can model the surface of the body with less than 100,000 triangles. And it's just that although we have a lot of folds in our skin and limbs and things like that, you can still model it with a relatively small number of triangles. But to model a ribosome, say, it takes nearly 300,000 triangles. And of course, a ribosome is much, much smaller than the human body. But a ribosome is the thing where, RNAs dock to produce amino acids. It's this sort of translation mechanism. It's the place where translation happens. And so this ribosome is they're very small, but they're very complex. They're very geometrically complex. And so it takes nearly 300,000 triangles to render a single ribosome with a surface view at atomic resolution. Even a small scene of a few proteins can contain tens of millions of triangles, and drawing every individual one of them at every frame can easily exceed the capacity of modern GPUs. So to overcome this issue, here we take advantage of a video game engine and demonstrate its capability of rendering large numbers of macromolecules at atomic resolution simultaneously and interactively. So they've done this. They're using the new virtualized geometry of Unreal Engine 5 called Nanite. And so Nanite allows you to render objects at different levels of detail based on the object, the distance from the viewer to the object. So you can reduce the number of triangles needed as you're viewing it from far away, but if you're viewing it close up, it increases the coverage in terms of triangles, in terms of resolution. So this is a good paper to go into to kind of get at this problem of biological modeling and modeling more generally. Now it looks like Sarrah had to leave and Himanshu had to leave. Thank you for attending, and your feedback on Sarrah's presentation was great. Thank you. Okay, so now I want to, well, I don't know if anyone had any comments on that paper. Okay. So no one, oh, go ahead.
Super interesting.
Yeah.
I mean, you know, and yeah, is Unreal Engine open source?
I'm not sure. I don't.
Is it kind of like Unity? It's just
well,
like
yeah.
free download.
I think free download. Yeah, it's a free download.
Yeah.
Vrushali?
Yeah, it's like Unity only. Like I have used, it's a game engine. You can make games or anything like stimulation and like you made in Unity. It's similar like that.
Sure, but I mean, you know, there are things like Godot.
Yeah.
You know, there are alternatives.
Yeah, I don't think it's open source in the open source sense, but like it's free. It's not like
Right.
you have to pay.
Right. I don't. I mean, I would be really interested to, you know, talk with people who know, you know, the space better in terms of the level of tech that they're talking about with Nanite Engine, you know.
Yeah.
Because as well as like, yeah, is there anything? Well, like I said about 3D engines, right? So I think Hussein was maybe talking about generating synthetic data with one of the engines. Like you can use these 3D engines for different things, right? So some for robotics, some for you know, ray tracing, some for yeah, like focused on the interactions, like game development. So yeah, so it definitely, well, it's a super cool. It's definitely a really cool paper, though, or a really cool implementation, and just to reiterate, because there's some developers with the Paris group that have been really interested in, you know, the segment anything release, and you know, in particular, looking at electron microscopy data. But there is a really interesting data release of Cryo-EM data from the James Zuckerberg Institute. Oh, and they're both looking, you know, they put it out there as a kind of segmentation challenge, but this is taking it to another, you know, I mean, what's interesting about this paper is taking it to another level. And I posted the tweet that I saw that linked to this paper, and Yuri Manin is the guy. He was one of the presenters at this advanced microscopy workshop at Berkeley. Mm-hmm. So yeah, like he you know, as a microscopist, and definitely like because he's really focused on in this case hearing loss and the kind of the proteins that are involved in the mechanics of hearing, right? So, you know, very interactive, right? Anyway, so you can check his tweet, but it's yeah, he saw some real utility in this, you know. Right. This isn't just a pretty, you know, pretty videos or something. Okay.
Yeah. Okay, so now I'd like to turn to this. So I want to follow up from last week. We talked about unorganized machines, which is a thing that Turing developed, or he talked about in his sort of from his seat in the 1940s and early 1950s. And so this was before Connectionism. This was before, well, it was kind of like contemporary with Pitts and McCullough. So, you know, these are different types of unorganized machines where you start off in development with these randomly connected neural networks, and then they get refined by modifiers as you go through development, and you pick, the modifiers are basically semantic tags that specify the network. So it's kind of like what we saw with the visual cortex, where you get this overproduction of synapses, and then you prune the synapses as development proceeds. So the first thing I wanted to actually point out is last week I didn't pull this up, but there's this tutorial by Tom Godot on Medium, and this is let's build a perceptron in Python. So if you're interested in building a perceptron, you can do this very easily in Python. And a perceptron, again, is where you have a bunch of inputs that go into this summation thing. So you have inputs from 0, 1 to 0, or x0 to xn, and those inputs have weights. So they go into this summarizer, this integrator with different weights. So you might have 2 of these nodes that are heavily weighted, and so the output will overrepresent these 2 nodes over the rest of these. The point is that this model can be trained to optimally sort of, these weights can be trained so that they optimally take in the right inputs and filter out the less optimal inputs and give an output that's refined. And it can teach it to do these things. So it's like perception, where you have a lot of different perceptual streams coming in, and you filter the information to give an output. So you can implement this in Python very easily. He goes through the math of a perceptron, then he goes through the Python code. And this is, of course, if you want to do this in a notebook, this is something that we talked about perceptrons or using the perceptron model to model what's going on in plants and information processing in plants. So it's a good tutorial if you need one. But I wanted to highlight some of the papers that were discussed last week. This first paper is I think it's from The Evolution of Intelligence or Evolving Intelligence. This is Craig S. Webster, and this is a paper on Alan Turing's unorganized machines and artificial neural networks, his remarkable early work and future possibilities. So this was a technical report submitted in 1948. He talked about these unorganized machines, and then I don't really think people picked up the work after that. I mean, it kind of sat there, and there's another, this is kind of like maybe like the earliest genetic algorithms. So, obviously genetic algorithms didn't even get mentioned again until like the late 60s, early 70s with John Holland and people like that. But this was sort of the first genetic algorithm, because it was doing this where it was like replacing one component with another, and it was optimizing the operation of a network and everything else. So Turing may have been the first to suggest using randomly connected networks of neuron-like nodes to perform computation, and proposed the construction of large brain-like networks of such neurons capable of being trained as one would teach a child. So this was not only a developmental model, but it also had a very strong genetic algorithmic component to it, well before that idea was really worked out in detail. So this paper kind of goes over the definition of a unorganized machine and some of the history. He gives some interesting examples of them. So this is a B-type connection modifier as he sees it. You have these different components. The signal gets passed through this network. The signal might get converted. It goes through an interchange. It might get converted to one thing or another. You can follow different alternative pathways through this network, and that's the solution to your problem. So that's kind of how it works. Turing did a little bit more than that, and then he put these things together in a larger network. So you have A-type machines, which are only capable of modification by what they call a screwdriver inference. I think he's using an example here. So Turing calls such modifications interference with the structure of the machine, and defines 2 types of such interference in delightful pre-electronic age terms. as screwdriver interference and paper interference. Screwdriver interference involves physically removing, adding, or altering parts of the machine, and today can probably more easily be thought of as hardware alteration. Paper interference involves feeding the machine new information that may then alter the logical behavior of the machine and would more easily be thought of today as software change. So, like, he thinks about sort of A-type machines as being this hardware layer, and B-type machines replacing A-type machines in the network as being like the software layer that gets added to it. So B-type machines have the specialized facility of a connection modifier between each network node. So they're capable of this more interesting paper interference, which is the set of values stored in the connection modifiers at any given time acting as a kind of software for the network. So it's interesting that he sees development as like this. You start with a hardware implementation and then you move up to a software implementation, much like if we had a sort of an innate mechanism in development that gets replaced by a learned mechanism in development. So this paper gives a lot of information about that. But there's another paper too that's more recent, and this is Christoph Tucher, really interested in A-life and some of these unconventional computational models. And so this is a paper, it looks like it was some sort of conference paper. I'm not really sure where it was published, but this is a revival of Turing's forgotten connectionist ideas, exploring unorganized machines. So this is, like I said last week, was connectionism before connectionism became a thing. So Turing had already investigated connectionist networks at the end of the 40s, and was probably the first person to consider building machines out of very simple round-like elements connected together in a mostly random manner. The present paper aims to revive and shed more light on Turing's ideas. Turing's unorganized machines are analyzed, and new types of machines are proposed by the authors. An example of pattern classification task is presented using a Turing net and genetic algorithms for building and training the networks. So this kind of combines the old idea of Turing nets with modern genetic algorithmic techniques, and he tackles this problem of, I guess he's using some pattern classification task. So in a little-known paper entitled Intelligent Machinery, Turing had already investigated connectionist networks by the end of the 40s.
So apparently there are two Charles Darwins.
I guess, yeah. Oh, Sir Charles Darwin, I see what you mean. Dismissed the manuscript as a schoolboy essay. So yeah, Charles Darwin, there was a Charles Darwin in the 19th century and a Sir Charles Darwin later. I don't know if they're related, but be interesting.
He did have a lot of famous relatives, so it could be.
Yeah. So yeah, anyways, so this came out in the 40s. There is no doubt that Turing's work on neural networks goes far beyond the earlier work of McCullough and Pitts, which of course is the biophysical basis of a neuron model that we know and is sort of the basis for neural networks, although neural networks kind of don't worry about the biophysics as much. However, it is interesting that Turing makes no reference in the 1948 report to their work. Turing's idea of using supervised interference to train an initially random arrangement of units to compute a specified function was new and revolutionary at the time. So it was far from being the schoolboy essay. But there's also this component of what they call random boolean networks. And this was another thing that sort of Turing was a pioneer in, because this is a technique that would come out later, especially Stuart Kauffman in his NK networks, where he would use random Boolean networks to model complex systems. So this work by Stuart Kauffman was in the 80s and early 90s. So this was, pretty far beyond that. And so what Turing is proposing is not only sort of a connectionist model before connectionism was a thing, but random Boolean networks before NK networks were a thing. So that's an interesting thing to think about. So there are a lot of precursors of cognitive science and complexity theory in this one paper. So Igor Alexander is probably one of the few researchers that consider weightless neural architectures as a serious alternative to modern-day connectionist architectures. So actually, one of the things about these machines, these unorganized machines, is that they're not weighted. So they're actually these binary systems. So we saw that network before. We have perceptrons, which are weighted networks, and then these unorganized machines, which are technically not weighted. They're binary outputs that get generated. So there's some threshold, and then there's a binary output. So we don't actually have weights in these networks, in neither the A-type nor the B-type. So one research about Turing nets go far beyond Turing's proposals, or our research about Turing nets go far beyond Turing's proposals. Turing's unorganized machines, namely A-type and B-type networks, are analyzed and described in detail in section 2. So they kind of go over some of this. They give a historical summary, and then they give some. They use this to solve a pattern classification problem. And they actually introduced something called a TB-type network, which is a variation on the A and B-type networks. So this is interesting. They kind of advanced Turing's work a bit. So they talk about A and B-type machines. They give some results, and then they give a TB network, which is this sort of variation on the A and B type networks. So this is interesting work. I guess they had problems with implementing some of these, so they invent a new type of machine. But this is a good instance of how these kind of ideas can be revived and brought into the present. One more paper to just kind of highlight a little bit. We're not going to get into it too much, but we're thinking about like historical things, and we think about connectionism and where kind of its origins. Connectionist models kind of came about in the 80s. And one of the things, and I found this interesting because this paper kind of talks about some of the shortcomings of connectionist models, and they kind of parallel some of the things that are going on in our conversations about neural networks today. So, we talk about AI ethics and some of the auditable models that we can build. They were thinking about these things with connectionist models back in 1982. So this is an article from Cognitive Science in 1982. Dana Ballard, who's a computational modeler, and J.A. Feldman. And this paper is Connectionist Models and Their Properties. And so this is a very short abstract. Much of the progress in the fields constituting cognitive science have been based upon the use of explicit information processing models, almost exclusively patterned after conventional serial computers. An extension of these ideas to massively parallel connectionist models, and this is where we get into parallel distributed processing, which would come later in the 80s, and other things. So the idea is that you're processing data in parallel, not just serially. A lot of times, early cognitive science was about serial computations or serial processes being the sort of the way that information gets processed in the brain. But connectionist models kind of said, no, these things happen in parallel, and you have an output that's sort of the product of these parallel processes. So in the brain, that would be like different brain areas engaging simultaneously and producing an output. So this built up to sort of these connectionist models. Connectionist models appear to offer a number of advantages. After a preliminary discussion, this paper introduces a general connectionist model and considers how it might be used in cognitive science. Again, this is 1982, so these really haven't hit the mainstream yet. Among the issues addressed are stability and noise sensitivity, distributed decision-making, time and sequence problems, and the representation of complex concepts. So they're trying to sell people on connectionist models. And to do so, they had to sort of benchmark them, or at least consider how they might be, some of the pros and cons. And so that's what they do in this paper, is they kind of go through this. And so they focus on a particular formalism, connectionist models, which is based explicitly on an abstraction of our current understanding of the information processing properties of neurons. And so this is where they introduce this idea of, connectionism and how it differs from conventional models of information processing that predominated in cognitive science up to that point. So we have a lot of things in the chat here. Let's see. Yeah, Vrushali had to leave, so thank you. And I think we talked about most of these. So thank you, Amanda. Amanda says very cool papers this week. So thank you. Is there any comments before we go?
No, just yeah. You obviously you can, as you can see with searches on this, that you can connect this to gene regulatory network modeling, and it's certainly that was where I was introduced first to that kind of boolean complexity that can arise, right? And but super interesting, and it's an incredibly British response in terms of the schoolboy essay. Like, really, that's. Okay. I think Turing had already proved himself at that point. Like, I don't know how that sir got his sir, but I think it might have been family.
The name, yes.
Great stuff.
Yeah, thanks. So yeah, Jesse had to leave, and so let's leave it there for this week, and talk to you next week.
Talk to you soon. This was great.
Yeah. Bye.
Bye.